Now today's our lecture is about standard 11 chapter 12 numericals. So first numerical, these data are given water flow rate which is 3 liter per minute. So in 1 minute 3 liter water is flowing. Now temperature changes from 27 degrees Celsius to 77 degrees Celsius. So initial temperature T1 27 and final is T2 77 degrees Celsius. Now difference of this temperature is 50 degrees Celsius, that we know. Now heat of combustion for this particular material is 4 into 10 raised to 4 joule per gram. Specific heat of water, which is always fixed, 4.2 joule gram inverse degree Celsius inverse. Mass of flowing water, that we know, 3 liter per minute. Now liter in gram is 1000. 1 liter is equal to 1000 gram. So 3000 gram per minute. Now we need to find here rate of consumption. So rate of consumption of heat, that formula is delta Q is equal to mc delta T is equal to 6.3 into 10 raised to 5 joule per minute. So this answer, by putting all the values here, we will get this answer. So what is rate of consumption? Rate of consumption is this rate of heat upon this heat of combustion. So rate of heat upon heat of combustion, we will get this rate of consumption. Now in this second numerical, mass of nitrogen, it is given. Rise in temperature is also given, 45 degrees Celsius. Molecular mass of nitrogen, that is 28, right? Because here N2, N is 14, 14 2s are 28. R is fixed. We need to find delta Q. To find delta Q, we have to find N, number of moles. So to find number of moles, M upon M, mass of substance upon molecular mass, it will 0.714. Now to find delta Q, again we need to find Cp, specific heat at constant pressure. So 7 by 2R. By putting values we will get this answer. And now at last delta Q formula is NCP delta T, and we have Cp and delta T. We will get 933.38 joule. Now next 12.3 you need to do in homework. 12.4 initial pressure inside cylinder P1, final pressure P2, initial volume inside cylinder V1, final volume V2, right? So here in this question we have to find P2 upon P1, ratio of these pressures. Now gamma is equal to 1.4, that is given. So for adiabatic, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So this process is of adiabatic, that's why we have to use this formula. Now in the question they have given final volume is compressed to half of its initial volume. That means V2 is equal to V1 by 2. So by putting this term here, we will get P2 upon P1 is equal to V1 raised to gamma upon V1 by 2 raised to gamma. So V1 gamma cancel out. We are only left with 2 raised to gamma, and gamma we have 1.4. So by calculating we will get 2.639. Now next numerical 12.5, the work done on the system while the gas changes from A to B, that is 22.3 joule. So work done is given. Delta Q, heat transfer is 0 here. So work done on the system, that's why we need to write minus negative sign on the system. And total formula, that is of delta Q is equal to delta U plus delta W. So delta U, internal energy that we have to find. So subject that delta U is equal to delta Q minus delta W. So 0 minus minus becomes plus. So that is our internal energy in positive. Now when the gas goes from A to B, delta Q 9.35 calorie. So 9.35 calorie into 4.19 is equal to 39.1765 joule. So again We have to find delta W for this delta Q. So delta W now 39 that we have delta Q. So by putting delta Q here, delta U, where is delta U here? So by subtracting these two terms, we will get 16.8765 joule. Now next 12.6, you need to do it in your homework. Now 12.7, work done by the steam engine per minute, that is W is equal to 5.4 into 10 raised to 8 joule. And heat supply from the boiler H is equal to 3.6 into 10 raised to minus 9 joule. So these two terms are given. We have to find eta, which is efficiency. To find efficiency, we have to take ratio of these two terms, W upon H. So we will get 0.15. So to find efficiency in percentage, we need to multiply this term with 100. So efficiency is equal to 15%. So heat wasted is 3.6 into 10 raised to 9 minus 5.4 into 10 raised to 8, because these are wastage of heat. It is 30.6 into 10 raised to 8 joule. Now next, heat is supplied to the system at a rate 100 watt. It is given. See this 100 watt, it is power. So we can write watt. So we can write Q is equal to 100 joule per second. So Q heat supplied, that is 100 joule per second. In 1 second 100 joule will be supplied, right? Now system performs at rate 75 joule per second. So this is performance of that system. That means this is again power of that system. So W is equal to 75 joule per second. We need to find U, internal energy. We know that formula Q is equal to U plus W. So U is equal to Q minus W. 100 minus 75, that will be 25 joule per second. So it is 25 watt. Now 12.9, again you need to do it in your homework. Now 12.10, refrigerator temperature, which is T1 9 degree, it is given, and room temperature 36 degrees Celsius in Kelvin, 309 Kelvin. So it is given refrigerator temperature and room temperature. Now we need to find coefficient of performance. So coefficient of performance alpha is equal to T1 upon T2 minus T1. So we have both the terms T1 and T2. By putting values, we will get 10.44.